looking at chapter Additional Mathematics, chapter 5, Equations, Inequalities, and Graphs. Okay, without much ado, let's begin. Now, let's take a look at which type of equation we're looking at today. Today, we're looking at how to solve graphically or algebraic equations of the type ax plus b, the modulus of ax plus b equals to the modulus of cx plus d. So we're looking at those type of equations, how to solve this type of equation. Okay, so today we'll be dealing with these questions or these equations of this format. Now, without this, let's take a look at a peculiar example. Now, if we have solving equations of type ax, the modulus of ax plus b equal to the modulus of cx plus d. Okay. Now, we say solve the equation, the modulus of 2x minus 5 equals to the modulus of x minus 4 using the algebraic method. So we have to solve this equation using the algebraic method. Remember, modulus means that both negative and positive are embedded to be positive. It means when they give you something like this, it could be negative as well, it could be positive. So that's what made it modulus. Modulus means, for example, if you say 4, 4 is actually, if we say the square root of 4, remember, is negative 2 and positive 2. It's negative 2 and positive 2, that is negative. So both numbers gave rise to 4. If you square this, if you square negative 2, you're going to get 4. If you square this, you're going to get 4. We collect what? Like terms. Second instance, you introduce negative in the second part of the modulus, the one on the right side, you introduce negative. So you say 2x minus 5 equals to minus, then you open a bracket 4 minus x. So we expand this one, minus times plus x. So on the right, we now have minus 4 plus x on the right. Now we collect like terms. On the left is still the same thing, 2x minus 5. On the left, it's still the same thing, 2x minus 5. On the left is still the same thing, 2x minus 5. So we collect like terms. When we collect like terms, you bring x to x. So you bring this x to the left, it becomes 2 minus x. If you bring this x to the left side, it becomes 2x minus, because this x on the right goes to the left, becomes minus x. So it becomes 2x minus x, that's x, or 1x, whichever language you want to use. 2x minus x equal to x. Then on the right, we have minus 4, then you bring plus 5. This minus 5 on the left, when it comes to the right, it becomes plus 5. So it becomes minus 4 plus 5. Minus 4 plus 5. So minus 4 plus 5 is equal to 1. Minus 4 plus 5 equal to vector also. When we say vector v, find the modulus of vector v, like this, we do like this, we do like this. Meaning you go to square, okay? For this one way of doing it, use minus in the second case. In the first case, you don't introduce any minus. You write the way they are inside the modulus. Write them out and collect like terms and find x. In the second instance, you introduce negative on the right, and then you collect like terms. You expand and you collect like terms. And so that's one method. Another method of doing this, another way of doing this, is to square both sides, the left and the right side. So modulus is actually like your squaring. You square to remove negative. So if we square 2x minus 5, and then we also have to square 4 minus x on the right. So if we square this, we can expand. 2x minus 5 means 2x minus 5 square simply means 2x minus 5 in one bracket, and 2x minus 5 in another bracket. Simply means 2x minus 5 in one bracket, and 2x minus 5 in another bracket. That's the meaning of 2x minus 5 square. That's the meaning of 2x minus 5 squared. So when you have, then you have to expand this. You have to expand this one. How you do that? You say 2x times 2x, you get 4x squared. You get 4x squared. Negative 10x. Then the next one, you say negative 5. You are done using this one to multiply the whole of this bracket. Now you take this one to multiply the whole of this bracket. Say minus 5 times 2x. You get also Okay, we took this one just now to multiply this. Okay, we got this. Now you say minus 5 times 2x. We also get another negative 10x. 5. So you collect like terms. When you collect like terms, negative 10x, negative 10, negative 10x, minus 10 minus 10x, that's negative 20x. So we have 4x squared. We have 4x squared minus 20x minus 20x, because minus 10x is minus 20x. So we get minus 20x plus 25. So this is the first expansion. So it becomes a quadratic, right? It becomes a quadratic. You see it's a quadratic function. So that's how we got this one on the left. 4x squared minus 20x plus 25, okay? Then you also do the same. You expand 4 minus x. You square both. 4 minus s, you square it, and then you expand it. You will get 16 minus 8x plus s squared. Then when you reach here, you collect like terms. You collect what? Like terms. Meaning, the one with x, they go one side. The one with y, they go one side. The one with x, they go one side. The one, sorry, I say y. The one with x squared, they come first, followed by the x and x, the one with x, and then the constant. You add them together. Now let's begin. You say 4s squared. Is there any s squared here? Yes. There's one s squared here. So you bring it to the left, it becomes minus s squared. So 4s squared minus s squared becomes what? 3s squared. 4s squared minus s squared. 4s squared minus s squared. Remember, s squared means 1s squared. Okay? We fix this. Now minus 20. This 8x minus 8x on the right, bring it to the left, become plus 8x. So it comes here, become minus 20 plus 8, that's negative 12. Minus 20x plus 8s will be negative 12x. That's how we got this negative 12x. Is that okay? And then 25, you bring this 60 to middle. You bring 60 to the left, it becomes 25 minus 16. You get 9 equal to 0. Right? Now if you take a look at this, if you take a look at it, you can actually do what? We can actually divide by 3. All the numbers are divisible by 3 to reduce this factor so that we can factorize easily. So divide here by 3, you get s squared. Divide negative 12x by 3, you get negative 4x. Divide 9 by 3, you get 3 equal to 0. So when you collect everything to the left side, you equate to 0. Don't forget the way we do quadratic, normal quadratic. So when you find two numbers and when you multiply, you get 3. When you add them, you get negative 4. They are what? Those numbers are 3, negative 3, and negative 1. Negative 3 times negative 1, you get positive 3. Negative 3 times negative 1, you get positive 3. Negative 3 plus negative 1, you get negative 4. 1 in one bracket equal to 0. You equate each of them to 0. You say x minus 3 equal to 0, therefore s equal to 3. And then s minus 1 equal to 0, you bring this one to this side, x equal to 1. So these are the two solutions, which is the same as what we got when we used the other algebraic method. Okay, when we did this other algebraic method, so whichever way you follow, you're going to get the same solution. You're going to get the same solution. Either you just say 2x minus 5 equal to 4 minus x, or 2x minus 5 equals to negative, introduce negative to this other side. So you can find two solutions, s equal to 3 and s equal to 1. Or you square both sides and do quadratic and collect like terms, and then you get the same solution. We can plot this one, y equals to 2x minus 5, plot the graph, the modulus of the graph, okay, and then plot the graph of 4 minus x, the modulus of it, okay, the positive one, and where s is 3 and s. So this is graphical solution using graph, okay, but then you can use any method that you deem fit that is understandable. Now let's take a look at the second problem. It says solve the equation x minus 2 plus the modulus of x minus 2 plus the modulus of 3x minus 4 equal to 8 using algebraic method. Okay, using algebraic method, we write this first modulus x minus 2 out. Then we say equal to 8 minus this one. We bring this one to this side. We bring this 3x minus 4. We bring it, the modulus, we bring it to the right. Okay? Now we're going to deal with this. We just move this. We didn't do anything. We just move this thing to this side. It becomes minus modulus 3x minus 4. Close the modulus. That's the only thing we did the first step here. Okay, here we're going to create two equations. Use this one to create two equations. How? By putting positive in one and putting negative in one, like we did before. But we write this one the way it is, s minus 2. Just write it out the way it is. But on the right, you write this 8, because this 8 is a constant number. Write this 8. Then you say minus 3s minus 4. Okay? Then on the other hand, you introduce negative here. On the other hand, you write this as positive, you introduce negative here. That's to form the second equation. The first equation is to write it the way it is. This way, the way it is. 8 minus 3x minus 4, the way it is. The second way is to introduce negative here to this place and negative here. So this one becomes positive. And only this one, this 8 becomes negative. Like you introduce negative here on the right side. On the right side. So minus 8, minus, then you introduce another negative because minus become plus. That's why this one is plus now. Like, that's why it came first, because it's now positive. So in this way, you get one equation, and then you get the second equation. We solve this, each one differently. We bring the first equation, we solve. Now, to solve the first equation, we collect like terms. So we say x modulus of 3x minus 4 equal to 10 minus x. How? How is it 10 minus x? You know, remember, minus x. So that's how we got this 10 minus x. That's how we got this 10 minus x. And why keep it this modulus? Bringing this modulus to the left. We bring this modulus to the left. You know it's minus. This modulus, if you bring it to the left, it becomes positive. And then you bring this x and 2 to the right, we get 10 minus x. So you remove the modulus, you just say 3x minus 4, this one, 3x minus 4 equal to, we introduce negative to the equation we created, this equation we created. We introduce, you know, one we solve it as positive, the other one we have to solve it as negative. Just now we just wrote 10 minus x, right? We continue, we solve. Now we're going to introduce negative here. It will be wrong. So you say 3x minus 4 is equal to minus 10 minus x, right? And then this, you expand this, use negative to expand. Negative times 10 becomes negative 10. Negative times negative x becomes positive x. This positive x, you bring it to the left, it's going to be negative to one side. So it becomes 3x minus 4. This modulus, this 3x minus 4 modulus, we bring it to this left side. Then on the right side, we collect other numbers. We collect both the x and the numbers. Now we have negative 6. Yeah. Then we bring s to this side, is going to be negative x. But however, why is it positive here? Because it's like we interchange. You know, this one is positive. We assume this one is the right. We assume this one is the left. So it's like, for example, you are keeping this one on one side, 3x minus 4, and you are assuming you are bringing this one to this side. So x is positive. You bring 8 to go and meet this negative 2. So negative 8 comes here, it becomes what? Positive 8. So minus 2 plus 8 is going to be positive 6. That's why both of these are positive. You know why? Because we assume this one, we want to keep this one positive. So we don't assume we move it to the left. We assume, even though we are writing it on the left, we are assuming it's still on the same side, and we are assuming we're moving this one to the other side. So that's how we. Now, once we have this, you now introduce plus. You say this modulus, one modulus, or 3x minus 4 equal to negative. Is that okay? Now we collect like terms for each of them. We solve each of them differently. Now let's deal with the one on the left first. So you say 3x minus 4 equals to x plus 6. So you collect like terms, you bring the x to the left. So it becomes 3x minus x. That's 2x. And then you bring this minus 4 to the right. It becomes 6 plus 4. That's 10. Because you bring negative 4 to the right. So it's going to be plus. It becomes 6 plus 4. That's 10. So you divide both sides by 2, s equal to 5. Now, that's for. Or the second one, You say 3x minus 4 equal to, so you bring minus x to the right, to the left, it's going to be, so you have, sorry, this one is minus 4 on the left. When it comes to the right, it's going to be plus. So negative 6 plus 4, you get negative 2. Negative 6 plus 4, because remember this is negative 6 because of this minus. Okay? When you expand this, you get minus x minus 6. Minus x minus 6. That's what you get. When you expand, when you use this negative outside to expand this bracket, you get minus x minus 6. So when you bring positive 4 and negative 4 on the left, when it comes to the right, it's going to be plus 4. So when you add plus 4, add minus s, when you come to the left, it becomes 3x plus x. That's how we go for x. And then negative 6, this one is now negative 6. This minus 4, when you check modulus inequalities. Now if you are given inequality, how do you solve the modulus? You have 2x plus 4, modulus of 2x plus 4 is less than 8. So what you do is that you go to on the right, you go to put plus 8. On the left, you go to put less than negative 8. You go to introduce positive on the right, negative on the left. And you keep this modulus in the middle. And you have something like this. You write this modulus out. 2x plus 4 is less than. You have to introduce positive and negative when we are removing the modulus. When we are removing the modulus. So you say on the left, you say it will be less than negative 8. It will be less than negative 8. Now you made it a double inequality. To solve a double inequality, what do we do? To solve a double inequality, we can highlight this and solve it separately, or we can solve both together simultaneously, and also we can highlight this other one and solve it separately. Also we can highlight this other one and also solve it separately. Okay, remember double inequality. Okay, let's do the one on the right first. So what we have on the right is 2x plus 4 is less than 8. 2x plus 4 is less than 8. So you bring 4 to the left, it becomes 2x to the right. It becomes 2x is less than 8 minus 4. You know, when this one comes to this side, it becomes negative 8 minus 4. So what you have now is 2x equal to 4. 2x is less than 4, sorry. 2x is less than 4. That's what you have now. So you divide both sides by 2. Divide here by 2. Divide here by 2. So x is less than 2. S is less 4 because 4 divided by 2 is 2. So you say s is less than 2 on the right. Now let's solve the one on the left. Let's solve the one on the left. Okay, to solve the one on the left, you say minus 8 is lesser than 2x plus 4. You can solve both of them together simultaneously. So now we collect like terms. We bring this one to the left. Positive 4, when it goes to the left, is going to be negative 4. So now we're going to have minus 8 minus 4. We're going to bring positive 4 to the left, it becomes minus 4. Now it's less than 2x. Less than 2x. Okay? So minus 8 minus 4 is negative 12. So you write negative 12 is less than 2x. So you divide both sides by 2 in order to find x. We divide both the left and the right side by 2. Why? Because we want to find x. Divide here by 2 and divide here by 2. So if you divide this by 2, when you are reading to the back, you say greater than negative 6. Greater than negative 6. Even though you are using less than that sign, you read to the right first. You say s is less than 2 and greater than negative 6. This is your inequality. Okay? Once you solve the inequality, then you are as good as you are good. See, s is less than 2 and greater than negative 6. This is the inequality. And you can add both of them together, divide by 2. Minus 6, so that you can get the line of symmetry. Okay? You can get the line of symmetry. You choose negative 6 is here. You put a point there. And positive 2 is here. Put a point there. Add the two together, get line of symmetry. So negative 6 plus 2 divide by 2. So that we find the middle of the both numbers, the middle. So that we can get line of symmetry. So I can put it in inequality. So this, you add, you get negative 2. So the middle of both of them, you know how to draw your and then you sketch them. Choose to put them at y equal to 8, because the original equation, the whole equation is less than 8. Okay, we still have something, right? Okay, now let's quickly take a look at this. Quickly, just briefly. Let's one on the left and modulus of another one on the right. Okay, using the algebra, you write the modulus of this is less than or equal to the modulus of this, and then you find the two values and you put the two values in inequality. The bigger one, you say x is lesser than or equal to that one. The smaller one, you say x is greater than or equal to that one. And then you put. So you have 4 over 3, which is 1 point something on this side. And then you have negative 2 on this side for the quadratic. But this red one is the part that doesn't really show when you sketch. Thank you for joining us.